Okay, let's move to the question number 7. The polynomial p of x is defined by p of x is equals to 2x to the power of 4 plus kx cubed plus kx squared plus 17x plus 18. Where k is the constant, it is given that the x plus 2 is the factor of p of x. Find the value of k. Okay, we know that if x plus a is factor of p of x, then p of negative a, because this one is the factor, so x plus a equal to 0 and x is equal to negative a. So plugging the value of negative a in the polynomial equation, we will get 0 because this factor satisfy the polynomial equation. We will use this concept to solve the part A. So it is given that p of x is equals to the 2x to the power of 4 plus kx cubed plus kx squared plus 17x plus 18, and factor is x plus 2 equal to 0, so x is equal to negative 2. Plugging this x is equal to negative 2, we will have factor negative 2 is equal to 0. So plugging negative 2, we will have 2x, which is negative 2 to the power of 4 plus k time negative 2 to the power of cube plus k time negative 2 square plus 17 time x means 17 time negative 2 plus 18 equals to the 0. Okay, further solving, we will have 32 minus 8k plus 4k, and then 17 times negative 2 is negative 34 plus 18 equal to 0, and we will have negative 4k plus 16 equal to 0. Further solving, we will have k is equal to 16 over 4 and k is equal to 4. So we have calculated the required value of k. Part B, it is given that the equation p of x is equal to 0 has exactly two real roots denoted by alpha and beta, where alpha is an integer and beta is not an integer. State the value of alpha and show that b satisfies the equation. This one, we know that the one of the factor is x plus 2, one of the factor is x plus 2 equal to 0, so this is the root negative 2, which is alpha in this case. Another real root, which is beta, satisfies this equation. Okay, first show that the beta second real root satisfies this equation. To find this equation, first we have the polynomial, which is p of x is equals to 2x to the power of 4 plus k, which is 4x cubed plus k square means 4x square plus 17x plus 18. This is the polynomial, and this polynomial has a factor x plus 2. So if we divide p of x by x plus 2, so we will have the quotient. So 2x power 4 plus 4x cube plus 4x square plus 17x plus 18. You need to find the quotient so that we can find the beta, or you can use also the synthetic method also. To make 2x to the power of 4, x should be multiplied with 2x cube. So we will have 2x cube to the power of 4, and 2 times 2x cube is 4x cube. Subtracting, we will have here 4x square plus 17x plus 18. X should be multiplied with 4x to get the 4x square. So this one is x times 4x is 4x square plus 2 times x square is 8x. Subtracting, we will have this one is 9x plus 18. Now we need to have the 9x. So when x multiplied by 9, we will have 9x. So 9x and 2 times 9 is 18. So we have the remainder 0. So we can say that p of x when divided by x plus 2, we get the quotient, which is 2x cubed plus 4x plus 9. P of x is equal to the x plus 2 time, we have the another factor, which is 2x cubed plus 4x plus 9. Now this factor is alpha, which is negative 2. Now we need to find the value of beta from this equation. So we can say that 2x cubed plus 4x plus 9 will have one real root and complex root. So the real root beta will satisfy the remaining polynomial. So we can say that 2x cubed plus 4x plus 9 is equal to 0 will have real root beta. So this equation can be solved further by switching 4x and 9 on the right side. We will have negative 4x minus 9. So x cube is equal to negative 4x minus 9 over 2, which is equal to negative 2x minus 4.5. Cube root both sides. So we will have x is equal to cube root negative of the 2x minus 4.5. Okay, part C, show by calculation that beta is less than negative 1 and greater than negative 1.4. Okay, we know that this polynomial, remaining polynomial, which is the 2x cubed plus 4x plus 9 is equal to 0. This is the polynomial, we call it g of x. This polynomial will have three roots, one of which will be the beta. So we need to show that real root, which is beta, should be less than negative 1 and greater than 1.5. Okay, we plug the value of given values in the g of x. For example, g of 1 negative 1 is equal to 2 negative 1 to the power of cube plus 4 times negative 1 plus 9. And this one is equals to the negative 2 minus 4 plus 9, and this one is equal to positive 3. Now x is equal to negative 1.4. So g of negative 1.4 is equal to the 2 times negative 1.4 cube plus 4 times negative 1.4 plus 9. And this one is equals to the negative 5.488 plus negative 5.6 plus 9, and this one is equals to negative 2.088. So g of negative 1 is equals to the positive 3, and g of negative 1.4 is the negative 2.008. So it's mean that there is a transaction from positive to negative or negative to positive. So in between there should be a 0. There is a sign change. So it's proof that beta should be in between negative 1 to negative 1.4. Now, part D, use an iterative formula based on the equation in terms of B. In use an iterative formula okay, part D, use an iterative formula based on the equation in part B to find the value of beta correct to three significant figure. Give the result to each iteration to 5 significant figure. From part B, x is equals to the cube root of negative 2x minus 4.5. Okay, in iteration form, we can write it xn is equals to under root cube root of negative 2xn minus 1 minus 4.5. Start from x naught is equals to negative 1. So x when n is equals to 1, xn is equals to x1 is equals to cube root negative 2 n minus 1 means x naught or x0 minus 4.5, and this one is equals to the cube root 3 negative 2 times negative 1 minus 4.5, and this one is equals to the negative 1.357208. This one is x1 when n is equals to 2, x2 which is equals to the cube root of negative 2x1 minus 4.5, and plugging the value of cube root negative 2 times x1 which is negative 1.357208 minus 4.5. When we solve it, we will get x2 which is equals to the negative 1.21818. Now n is equals to 3, x3 is equals to cube root of negative 2x2 minus 4.5. So this one is equals to cube 3 negative 2 times x2, which is negative 1.21818 minus 4.5. By using calculator, you will find that x3 is equals to the negative 1.27118. Okay, when n is equals to 4, x4 is equals to cube root of negative 2x3 minus 4.5. This one is equals to cube root of negative 2 times x3. x3 is negative 1.27118 minus 4.5. Further solving, we will have, so x4 is equals to the negative 1.25298. Now n is equals to 5, so x5 is equals to the cube root of negative 2 times x4 minus 4.5. So this one is equals to cube root of negative 2 times negative 1.25298 minus 4.5. So x5 is equals to negative 1.25824. We need to find correct to the three significant figure. So we can see that this 1.25 is the correct significant figure. So we have calculated. So we can say that x is equals to beta, which is equals to 1.26, because when we round off, it will be 1.26. So this is the required value of the beta.